Hi, my name is Elle, and I am attempting to bring computer science to those of us who weren't born spewing forth ones and zeros. We all know people like that, you know? The people who were born with computer science majors slapped on their forehead, who were changing the language on their family's home computer when they were 3 to Chinese, and then changing it back when asked to do so. I am not one of those people. And yet, I'm a software engineering major, and I've found a lot of satisfaction in that. And I've also found a lot of struggle in it. It's taken me a while to get here. It was a big paradigm shift in thinking, and I want to extend a hand to others who are trying to get into the practice. Computers are scary to a lot of us. I have a lot of friends who love computers more than people, and I am not one of those people, because computers can't love me. Only people can. But one thing about computers is that they help people. For example, they're involved in family history, in DNA testing, in forensics, saving the innocent and convicting the guilty, and etc. And also, computers are pretty cool. Of course, pop culture hacking isn't like real hacking, but there's still that element of nerdy, I'm cooler than you in being able to program. Not that I think that about my friends, but anyway, so what is a computer anyway? Well, it's this. We use them all the time, but what actually is in a computer? How does it work? Of course, we never really think about that. The first time I was introduced to the inner workings, like on a base level of how a computer works, my mind was blown. It is so cool. So you might have seen the movie The Imitation Game, and Alan Turing's proto-computer. It is really cool. They used it to break a Nazi code creating machine. And it's an example of an early computer. It was different, though, because it was specifically made to break code. Anyway, so what a computer is founded upon is currents, electrical currents that are either on or off. Now, people found that with sets of these, we'll call them switches because they can be on or off. So with sets of these, which is called a circuit, you can actually calculate things. And then you can store information in memory, like pictures, where every pixel is put into ones and zeros, or sound, where everything is put into ones and zeros, and then replicated to a person, which is so cool. So originally, computer instructions were written in ones and zeros. This switch is going to be on, this switch is going to be off, and it got more and more complex. And anyway, writing instructions in ones and zeros sounds awful. So you've probably heard the joke. There's 10 kinds of people in the world, those who know binary and those who don't. Well, now you know, if you didn't before, that in binary, 1 0 is 2. 1 0 0 is 4. 1 0 0 0 is 8. But that can get pretty confusing. Can you imagine writing instructions for a computer in all ones and zeros? Yikes. It can get pretty complicated. So people figured out how to build a machine that could map words closer to human language into ones and zeros. This is called an assembler. And then eventually they figured out how to make languages that were even more similar to the way humans speak, put that into something called a compiler, and that would translate the human computer language into ones and zeros that the computer could understand and execute. So basically, now we can take something a human can write and turn it into something a computer can understand. And it spits out computer understood language. Okay, so what kinds of things do computers think about? Anyway, can a computer think about which colors go together? Can a computer decide which person you should date, since you're always perpetually ultra popular? Can a computer solve math problems? Well, we know that computers can solve math problems, and we know that a computer probably can't pick which person you can date, though AI is getting more advanced. But that is a debate for a different video and expert. So we know that computers think differently from us in some cold, unemotional way, kind of like Spock, but without green blood, let alone any blood. So computers think differently from us, and computer programming, like learning how to computer program, not the language, but learning how to utilize that language, involves learning to think like a computer. So normally when we write documents, we write them for another person to read. Like, here you go, and then the person goes, oh. But in computer programming, we are writing documents for computers to read. And the computer isn't going to take the document and decide what it thinks about it. The computer is only going to do what the document says. So sometimes we give documents to people to read and think about, and sometimes we give documents of only instructions. So, for example, my dad sent me an email the other day that said, please budget money for an emergency fund for Christmas presents and for Christmas break. But he said, please, he was leaving the decision up to me. When we give documents to computers, we're only giving them documents of instructions, and they must carry them out. Which is really awesome. Whatever we say goes. It can also be terrible, though, because if you make a mistake, that mistake is going to happen in the program. You might remember that in the PBS show Zoom, which I was very fond of as a child, that there was a little thing called the peanut butter experiment. You've probably seen it somewhere else. Or it's actually a game. So you have two people, and you tell one of them to tell the other one how to make a peanut butter sandwich. Only the one receiving the instructions has the material to do it. And what happens is that as the first person, the instruction giver, gives the instructions, the second person takes the instructions too literally, and it can be hilarious. For example, they'll put the jar of peanut butter on top of the piece of bread when told to put peanut butter on the bread, and more complications happen from there. But basically, the reason I'm talking about this is because computers are the worst partner in the peanut butter game ever. Because computers take our instructions at face value. So the biggest part about learning how to be a programmer, okay, that's arguable. But right now I'm going to say the biggest part about learning what it is to be a programmer is learning how to take tasks that you have in your head in human language and break it down into precise steps. And we know how to do that. That capability is in us, but you have to work on it. And it sounds complicated because you have to learn the computer's language, and you have to learn to think in algorithms, in little steps. But don't worry, it's much easier than getting a human to follow all of your instructions to the T. Thanks for watching, and you can please join me next week when I will be talking about how to run basic computer commands.